We are talking about diffusion.
Hey, that was in the next section.
And diffusion was what we talked about yesterday also. And osmosis. And our goal is to understand how particles and water move through cell membranes, or across. Okay, so yesterday, I don't have it here, but I did the demonstration where we put the drop of dye into a jar of water. Ruben, you weren't here. Who else wasn't here yesterday? Nicole wasn't. Yeah, why not?
Every single thing he writes, you put in.
No.
How does this work, though, when you can't even read the words from that thing?
You can't. Well, when you put this on a computer, it's bigger.
True that.
True that. Okay, let's see.
You just said that.
Yeah.
No, you said the other one of that.
What?
You said that is the... You actually said...
True that. Are you guys arguing whether I said dat or that?
Yeah.
No.
Really?
You can't say the second one. You just said you have to say that.
Yeah.
I understand. I understand that.
That's good.
Oh my gosh.
I don't understand what the other word means.
Interesting.
Okay. So that's a bunch of stuff. That's a bunch of particles. And over time, what we talked about was natural movement of particles causes things.
And that's what happens.
To spread out, right? Because particles are moving, and random motion causes them eventually to be basically evenly concentrated, so that eventually there will be the same amount in any one area. That's sort of what that means. And what this is called is a concentration gradient.
Dang. So we're gonna get asked questions about this?
You are. Yeah. I mean, you were supposed to. The other class had to read this last night. I forgot to tell you guys to read it, and so
Thank you.
you got lucky. But you may have to answer these questions tomorrow.
That's
Just so when I go through the notebooks, I won't be like, "Where's your questions on the concentration gradient?" and give you all zeros, because you know how I am. I forget
But I mean,
what I did in one
the
class.
whole class forget something, then I mean you should remember.
Eventually, I'm like, maybe I didn't.
But a 20 student,
Yeah. Yep.
you forgot.
So concentration gradient goes from high concentration
Too low.
to low, right? And that's the natural order of things. High to low concentration is normal. Right? This is, no one would expect anything different. It's normal if you have stuff to have it spread out as time goes on. If you do the opposite, that is not normal. So if you go from low to high, concentration, not normal. Not natural.
I mean, put normal down.
Or normal. Not natural or normal. There, how about that?
Okay.
It is neither natural nor is it normal. Life is about doing the opposite, but we'll talk about that. Life processes often will gather stuff back in. Think of it this way: clown car, clown car. Clown car comes into the circus. 50 clowns come out. Right? You guys know what I'm talking about?
Yes.
Clown car? Yeah. Okay. Just like everybody's like, clown car. 50 clowns come out. That's totally normal. Clowns come out of the car, they spread out. What is much more difficult is getting all the clowns back into the car. So, like, there's the clown car. There's all the clowns spread out. And the point is that it's sort of very difficult to get all the clowns to go back into the car. It takes a lot more. It takes a lot of energy, whereas this just happens
I
normally.
feel like it'd be hard to get them out.
That's what I was thinking, because if you're all crammed,
I don't know.
I mean, if you open the door and the first one falls out, then you got a little space.
Well, I mean, all the clowns are gonna come out.
Clowns repel each other. Clowns tend to repel each other. They're, well, I don't know.
Anti-clown.
They repel me a little bit, but. Okay, so how does this play out? So why do we care? Because we care about living things that have cell membranes and how things move into them. Like, for example, I have here. Okay, I need you guys to be talking less and paying attention to this more because this is important, and you're going to make this take a lot longer if I have to keep. If you guys keep breaking into song every time I turn back. Yeah. So here's a cell, and the cell's in a beaker, and there's a whole bunch of stuff dissolved in the beaker. Could be salt, could be sugar. It really doesn't matter. That's the whole thing. But the natural tendency is for it not to stay like this, because what do we have here? We have an area of high concentration. Here, I'll spell it out for you. High concentration, low concentration. So what's going to tend to happen here?
It's gonna go inside.
That's right. I know it's not.
Aren't you supposed to go left to right, sir?
I knew someone was going to say that. I just wanted to stay
like
on
that.
screen. You don't like it?
No, you can stay on the screen over there.
I know. I just decided to be contrary, actually, and then I lied about it.
Are you a pathological liar?
Not pathological, but occasional. I lie to you guys all the time.
How do you say that and live with yourself, sir?
Is that a lie?
I sleep soundly.
Yeah,
that
is
is
that
not
a lie?
a lie. I sleep pretty soundly.
Is that a lie too?
No, it is not. But now you'll never know. So here we go. Oh God, I should have written on the other side. You're right, but that's okay.
Uh-oh.
I did.
So now we've reached a state where you have basically equal concentrations on either side. Now, what you have to understand is that there's no like person with a clipboard going, wait, no, too many out here. Let's bring one more in, one more in. You know, it's not like that. It's a natural process that's just due to random motion of all these. It just sort of works out that way. Yes?
Is that black thing the nucleus?
It is. That's correct. It's the universal sign for this is a cell. It's blobby shaped and it has a dot in the middle. So, okay, but what we've reached, and this is, I think, the last vocab word for diffusion. We've reached a state of what's called dynamic equilibrium. I will do my best to write it as if I really know how to write letters. Look at that. My I's have dots, my M's have two humps, my B actually has a little loop on it. I have to say those
Except
are...
for you spelled it equilibrium.
Oh, crap! I was concentrating so hard on writing letters.
Equilibrium.
Wait, actually, I spelled this right. Equilibrium.
Hey.
Equilibrium. It's reached a state of dynamic equilibrium. Alright, what does that mean? What it means is that it's not, again, there's nobody with a clipboard, there's nobody
equal
making sure
everywhere,
that this is right. It's equal everywhere, but the dynamic part, right, and that's absolutely right. The dynamic part, though, means that it's still moving. Dynamic means moving. And so it means that there's still particles moving in, and there's particles moving out, but the rate is about the same. Once you reach dynamic equilibrium, you know, you have some that'll come in, and other ones will go out. And again, it's not like, oh, one went in, we got to send another one out. Wait, no, too many. It's not like that. It's just sort of like it happens that way. It's like I don't know what it's like. It's like when you have a party and there's, you know, you get to that point where some people are starting to leave and some people are still arriving. I don't know. I guess that's my example.
That does not make sense.
Okay, then never mind what I said.
I get it.
Get it.
I feel you.
It's like, okay, you're at McDonald's. Anyway, you're at McDonald's.
Yeah.
And the place fills up, it's lunchtime, and 2 people walk in. That doesn't mean 2 people are going to walk out right away, but they're coming and going at about the same rate. That's dynamic.
But at lunch hour, a lot more people are coming in.
Until a certain point, then it reaches dynamic equilibrium. Dynamic
That's
equilibrium.
the truth, man.
Dynamic equilibrium. Okay, that's all well and good. So that's part 1, and part 2 is not as bad. Part 2 has to do with something else. Wait, everybody, take a minute and make sure you get that. Yes, hello, I'm Mr. Armor. So now we're going to pretend that we have a membrane of some sort, and it's semi-permeable, and we've got a bunch of
Do we
How do
take
we?
the whole page doing this? Or?
no, you could just draw a little picture.
Oh my boy.
Okay, so we've got water, and then we've got something dissolved in water. Let's make it green. Let's say,
But we can't do
well, you could if you had 2 colored pens, like I wanted you
Shots fired.
to. Shots fired,
Yeah.
indeed.
Bang, bang. with this.
Okay, so here's the thing. Normally, the thing about diffusion is that we would end up with, what, 3 on each side, theoretically, right? Or thereabouts. Sometimes 4 and 2, sometimes 3 and 3, sometimes 2 and 4. But, so you'd have half of them over here. But let's pretend that these can't get across. So we've got a membrane, but these fail at getting across because they're too big. Or it could be that they're too highly charged. They could be sodium ions, and the cell membrane is nonpolar, and so things that are polar or highly charged have a very hard time passing through the membrane. And so we can't move from high to low concentration. Or can we? Is there anything here that can move from high to low concentration? What else has a high to low concentration gradient here?
Oh,
The water.
Water, right. Don't forget, this is water. So we have all these water molecules here. And I want to remind you something, and I swear to God, we're just a few minutes from being done. So just stay, you guys are doing really
oh man,
pretty
I
good
want blue.
job.
I need
What?
a little one.
I have blue.
The point is that we also have water molecules. And let's remember something. Why do things dissolve? Because they and the water molecules are attracted to each other. There's an attraction between the water molecules and the things that dissolve in them. Little, like either hydrogen bonds or some sort of attraction. It's not a real bond, but they're actually attracted. And so, but if you think about it, high water concentration over here and a low water concentration over here. I know, I wrote concentration, but you know what that is supposed to say. It's supposed to say concentration. And so water will also move from a high to a low concentration because the water molecules can move back and forth. So what happens is the water molecules will go across until they... Okay.
You don't even know what you're doing.
I totally know what I'm doing. I went to college, man. No, I'm trying. I'm struggling a little, but that's okay. But the point is, the water will actually cross the membrane. If the particles can't, then the water will. And that is called, anybody?
Osmosis.
Osmosis, right? That was the one thing we were talking about. So this is osmosis. Oh, right. Osmosis, movement of water from high to low concentration. So it's just the diffusion of water, really. And this will actually happen. This can actually cause there to be more water on one side of a membrane than the other. Okay, so take a minute, try to write that down, and then I'm going to show you an animation, then we're going to do a lab.
Okay.
It's going to be basically awesome.